Hello students, I'm going to introduce to you the stopping distance lab. Okay, stopping distance. Let me demonstrate. Okay, I've got a surface here. It's an aluminum dynamics track, and the cylindrical mass you see pictured here in the diagram. And we're simply going to give this a push, and it's going to travel a certain distance. And the faster I push it initially, it travels further. Ooh, way further. All right. So, how are we going to capture the initial speed from once I let it go? Okay, as soon as my hand's no longer pushing it, we're going to use this fancy piece of lab equipment called a photogate. So, between here, there's an infrared beam, and when that mass blocks the beam, it'll know how long it's being blocked, and the width of that cylindrical mass and distance over time that it's blocked. Out comes the initial speed. Okay. The stopping distance will be measured with good old meter stick. Okay. Now, I'm not going to tell you everything about this experiment. You've done a couple of data collection and analysis activities, and I want you to kind of figure things out. So be prepared. I have a data table, so we've already discussed the parameters of the stopping distance lab, initial speed and distance, but I'm not going to tell you how to graph it, what goes on the y-axis or the x-axis.
Okay.
Come on, Mr. Holsworth, can you give us a hint or something?
Katie, Miss Titus, head of school, I am so sorry to disappoint you, but I just want to be fair to the other 3.8 million physics students taking this course. Oh, by the way, I just checked out your 21st century skills self-assessment, and you gave yourself a 2 out of 4. I gave you a 4 out of 4, just so that you know that I have great faith in you that you're up for the mighty task, choosing what to plot on the XY axis. So I'll stop there, and I'm going to now move over to the table from which we're going to start collecting our initial speeds and the distance traveled. Okay, here's the surface that we're going to slide the mass along. We have a photogate that's going to measure the initial speed of the cylindrical mass. The units are meters per second. We have a meter stick here to measure the stopping distance. I'll be calling out the stopping distance, but the stopping distance will be read in centimeters. So you're going to have to be consistent with units, and that's all I'm going to say about that. So let's get started. Your first data pair will be 0, 0 in your data table. So, okay. 6.25 centimeters. 6.25 centimeters. 15.5 centimeters. 15.5 centimeters. 20 centimeters. 20 centimeters. 29 centimeters. 29 centimeters. 38.5 centimeters. 38.5 centimeters. 44.5 centimeters. 44.5 centimeters. A little too far. I'm a bit of a perfectionist. 56 centimeters. 56 centimeters. 69 centimeters. 69 centimeters. 76 centimeters. 76 centimeters. Oh, that's a long one. I'm going to go with this one. So this is going to be 104.5 centimeters. So 104.5 centimeters. $87.5 centimeters. 87.5 centimeters. Let's make this our last data pair. 90 centimeters. 90 centimeters. Okay, I'm going to stop there. Organize your data table in ascending order. Okay, that's all I'm going to say about that. Plot the data and then model the data. In terms of the line or curve of fit, you have some resources in your textbook in Chapter 2. Assume this is uniformly accelerated motion. And I may or may not assign a physics problem that involves stopping distance, but in your search in Chapter 2 and perhaps if you find a physics problem in the problem section, you might be able to put some things together in terms of how to go about modeling this data. All right, there you go. Stopping distance.